Welcome to ChemVid. Today we are talking about units and measurements. So let's start off. If I was to measure the volume of a water bottle, what are two different ways to measure the volume of a water bottle and the size of binder clips? Pause and take a moment to answer. Alright, so volume can be measured in many ways. We have cups, we have liters, we have milliliters, we have ounces, we have quarts, we have all sorts of different units for measuring. Size of a binder clip? A binder clip can be measured in centimeters, millimeters, meters, miles, inches, whatever. It has a ton of different ways to measure. We have a ton of different units to measure the length of an object. So, if that's the case, what do all measurements need? Well, when we report measurements, they have to have both a number and a unit. Because we have so many different kinds of measurements and types of measurements, we have to be very specific and make sure that we say what unit we're using. Because 2 cups is very different from 2 gallons. So whenever you're reporting a measurement, make sure you have both. Alright, now that we're done with that, let's report on length. I want you to take a moment, and I want you to look at your piece of paper, and I want you to put the dimensions of your paper in inches, feet, centimeters, and meter. Go ahead, grab a ruler, and change your, measure your paper in all of those different units. Okay, so I measured 8.5 by 11 inches. These 2 little dashes mean inches. 1 dash means a foot. So now I have that in inches, but my ruler isn't precise enough to measure in feet. So what I do is I need to convert it using a conversion. I know that there are 12 inches in 1 foot, so if I take 8.5 inches and divide it by 12, I should get how many feet there are. That's because the inches divided by inches turns into 1. Anything divided by itself turns into 1. So the inches go away, and I'm left with the units that I want. So I do 8.5 times 1, divide by 12, and I get 0.708 feet. I do that with the other side, and I get 11 inches divided by 12 inches times 1 foot is equal to 0.9167 feet. So that's how I get into feet. But how do I go from inches into centimeters? Well, I can do the same thing. If I look on my ruler, I notice that 1 inch is equal to 2.5-ish centimeters. And if I look it up online, I can find the exact conversion, which is 2.54. So for every inch, I have 2.54 centimeters. So I do the same thing. My inches need to cancel out. I use a proportion. 1 inch is equal to 2.54 centimeters. I multiply across, divide by bottom. I get 21.59 centimeters and 27.94 centimeters for the other side. So now that I have centimeters, how do I get into meters? So centimeters and meters are what we use, well, anywhere other than America. Alright, and this type of measurement is based off of a 10 system. So centimeter, a centa means 100. That's what that prefix means, if you think back to biology. So I know that 100 centimeters equals 1 meter. So I can do the same thing as before. Take 21.59, divide by 100, and I get 0.2159 meters. However, because it's based off of a 10 system, I can also take my decimal place, and I can move the decimal place over 2 spots, because there are 2 zeros in 100, and it gives me the same answer. So whenever you're dealing with the metric system, this system of centimeters and meters and things like that, you can do it two ways. You can either do it using the proportion, like we learned for inches and feet, or you can do it by moving the decimal place, whichever one is easier for you. Now, the metric system has a lot of prefixes, which are listed here below, and we will go over those in just a minute. But first, let's take a look at what we call SI base units. So SI base units are what scientists call System International des Units. That's French. But anyway, it's basically the units that we use all around the world in order to keep our numbers constant. For instance, if I said I wanted a piece of wood that was 24 feet long, if I went over into, I don't know, Africa, Germany, anywhere else, they would look at this and be like, what is that? All right? And so they don't know feet. We know feet because that's what we use, but in other places they don't. So in other places, they're actually using the meter. Everybody uses the meter. Everybody needs to understand and know how to use the meter because it's what we call our international unit. It's what's used everywhere. And as scientists, we have to be able to communicate with everyone everywhere. Okay? So as I come over here, time, seconds, length, meters, that might be a little different to you. Mass is in kilograms, which may be a little different to you. We don't usually use grams, but most people do. Temperature is in Kelvin, and Kelvin is very special. We'll go over more about what Kelvin means. And then amount of a substance is the mole. Electric current is an amp, or an ampere. And how bright something is, or the luminous intensity, is a candela. So these are the units that we are going to be using and that transcend every single continent. So let's give these questions a try. What unit would you use to report the length of the classroom? What unit would you use to report the mass of a stapler? Go ahead and try those. All right, so if you chose meter, you are correct. Length is always measured in meters. And then since our classroom is pretty big, we might measure it in kilometers, which is a bigger measurement of meters, a bigger prefix. And for a stapler, we might use a centimeter because it's so short. So centi means 100, so it's a little shorter. And that way we can have some reasonable numbers. And we'll go over that a little bit later, like I said. So, sometimes we talk about big things or little things. For instance, the distance between Jupiter and the Sun. Whew! That is a huge number. 778. Let's see, that's 100 million, or thousands, millions, billions, trillions. That's a whole lot of meters, okay? And writing out all those zeros, well, after writing that a few times, I'm sure to forget a zero or something might get messed up. So another way to write this would be with what we call prefixes. So if you go down here, here's the kilo. We said it was 1,000. And centa means 100. So what this is saying is that instead of writing out all of these zeros, I use one of these prefixes to take its place. So let's count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. I look down here and I see, let's see, over here. There. See how it says 10 to the 9th? That means 9 zeros. So instead of writing out all 9 zeros, I can simply write 778, use my prefix, which is a giga, and then my units are meters. 778 gigameters. And that way it's a lot easier to write that number over and over and over again. So what about a helium atom? How small is a helium atom? Whew! That guy is extremely small. Look at that, 0.00000062 meters. He is very, very, very tiny. And that's a lot of zeros to write again. So what I'm going to do is I'm going to use a trusty little prefix. So I do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12. So my decimal point's going to be over here. So instead of when it's a big number, you stopped at the 0, but when it's a little number, you have to go all the way over to the last decimal place, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to write 62. Then I need a prefix that says 12. And if I look over here, well, there's no positive 12, but there's a negative 12. What does the negative mean? All these negative numbers right here are used for smaller measurements. Like a centimeter is pretty small, whereas a kilometer is really big. So since it's a small number, I want one with a negative 12. See how they go out all the way out like that? So I'm going to use a pica. And there's my picometer. So 62 picometers, instead of writing out all of those zeros. Now there is another way to write large and small numbers without using prefixes, which is totally fine. It's very valid. It's called the scientific notation. So if you look over here, if I write a 10 with a little superscript, it tells me how many zeros there are supposed to be. So if I look, I can do 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would write 778 times 10 to the 9th power meters. That writes out, that's the exact same number as before. It's just using scientific notation or using how many zeros there are in order to make it smaller. Now, with scientific notation, I can use it for small numbers as well. So 62 times 10, and we counted all the way over 12 spots. So this would be 10 to the negative 12th. Remember, negatives are used for really small numbers. Positive are used for really big numbers. So that's how you write really big or really small numbers in a more easy fashion. If you have a chance, you might want to look up this video right here. It shows you the difference between large and small things in the universe. It's actually quite good. Alright, last thing on today's docket is temperature. Now, you've probably heard of Fahrenheit. That's what we usually use. There's also a unit of temperature called Celsius and Kelvin. Fahrenheit is used in America, Celsius is used everywhere else, and Kelvin is used by us scientists. Because unlike Celsius and Fahrenheit, Kelvin is always positive. It's based off of what we call absolute zero, so you can never have a negative number. Celsius is based off of water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. So they picked those two numbers using water, and that's what Celsius is based on. So over here are my conversion techniques to get from one to another. Because if I give you a conversion, like a measurement in Kelvin, and I need to know what it is in Fahrenheit because I live in America, I'm going to have to be able to go through this. So I'm going to do this one right now. So my first step is taking 245 Kelvin and turning it into Fahrenheit. Now, if you look over here, I don't have an equation that relates Kelvin to Fahrenheit, so I need to go to degrees Celsius first. So Kelvin equals degrees Celsius plus 273. So I plug in my number for Kelvin. I do some algebra, bringing the 273 across by subtracting it, and I get negative 28 degrees Celsius. Now that I have Celsius, I can go to Fahrenheit. Fahrenheit is equal to 9/5 times Celsius plus 32. If I follow proper order of operations, multiply these two first, then add, I get degrees Fahrenheit is negative 18.4 degrees Fahrenheit. So by using these equations, I can go from Kelvin to degrees Celsius to degrees Fahrenheit just by using the proper equations. For homework, I'd like you to try this problem right here, and we will finish the rest of the notes next time.